Hello everybody and welcome to the second part of the Working with Gradle and Circle CI talk. So today we're going to talk about continuous deployment. Last video we talked about continuous integration and how to set up a pipeline. So we ended up writing a Gradle file to build our Java application. And we also wrote a Circle CI configuration file that spins up a machine in the cloud for us and does the build process and validates that our software is working properly. So in case you lost that or you want to go back to that tutorial, I'm gonna leave a link on the description so you can just click and go back and watch that. But right now we're gonna do CD, so let's jump into that. So just a quick recap, we're talking about Devops, which means that's the process between you, the developer, committing some code to GitHub or whatever service you're using, and that code going live, right? So instead of having some third-party person or somebody responsible for operations, you as a developer, you're going to push some code, you're going to write some scripts, and those scripts will create a machine on the cloud and will validate your code and do whatever it's needed to make sure that your software is good to go. So we no longer, like in the past, we used to have operations people, basically people that would get hired to be 100% focused on packing software and releasing it. With DevOps, the entire idea is that we're going to write a bunch of scripts that will do this job for us. Reason why is because right now we're dealing with agile practices. Things are moving super fast with Scrum, where for every 2 weeks we're releasing new things to our clients. And there's no way we can manage to allocate somebody to be specifically doing operations. And also because making things automatic, it's way more efficient than hiring somebody to do it. It's less error prone and it's generally just more efficient. So let's keep moving forward. So yeah, last class we talked about the code gets pushed to GitHub. GitHub will trigger Circle CI. We talked about webhooks and everything. So whenever Circle CI notices that a change came to our GitHub repository, it will create a machine on the cloud, spawn that machine for us, and it will run our script. And our script, inside of that, we actually run our Gradle file. And Gradle is responsible for building our Java application, packing everything, testing, verifying that everything's working properly, and even generating a jar file for us. So Circle CI is the service that provisions the machines, and Gradle is the tool that we're using actually to build our software and make sure it's running properly. Okay, let's keep moving here. So we talked about Apache and Maven and Gradle. Not going to go over that again, but we're using Gradle because it's the most modern approach. Just keep that in mind. We talked about applications like Jenkins versus software as a service applications like Circle CI and Travis. And for the simplicity of those the software as a service applications, we're using those instead of setting up our own server. But it's good to keep in mind that in case you want to make your own CI server, yes, you can definitely do that. Download Jenkins, play with it. It's open source and it's super interesting to play with. It's a nice platform actually. But for now, we're using Circle CI. We just need to write a YAML file, a configuration file that will describe how the machine in the cloud will do in order to test and verify that our software is running properly. Okay, we talked about webhooks. That's pretty much the way Circle CI is aware that GitHub got updated. So whenever GitHub gets some new code, it will just call a function inside Circle CI, a RESTful API actually, and that will trigger Circle CI and it will generate, create a machine and do all the stuff that we need to do. And okay, so last week we talked mostly about continuous integration, which it's sometimes in the community is also mixed up with continuous delivery. Basically, it's the process where you dev some code, you test it locally, then you merge that to a master branch and you integrate that with your peers code, and that gets tested. And in case you're and we're validating that your test cases get accepted. So again, going back to that use case where you have 3 people in your team right now, or 4 people working in different features, and everybody's will be working in a separate branch. Eventually, those branches will get merged to master, And whenever they are merged, you want to make sure that your test cases, the test cases that you wrote, and also the features that you've developed, they're not crashing whenever they get merged with other people's work. So that's the integration part. So running integration tests, the integration test part of this is basically validating that your code and your unit tests together with other people's code and unit tests won't break the application. And also you want to make sure that everything is green, so all the test cases are running properly and your software is building properly as well. In case this step fails, Gradle will let us know. It will outputs build failed. And so yeah, that's continuous delivery. Also, generally, it gets called as continuous integration by part of the community. So some people will be like, oh, I'm doing CI. They're also meaning that they're checking to verify if the tests are running properly or not. And finally, we have continuous deployment, which is the best. It's exactly what we want to reach in the end of all that, right? Obviously, we want to validate that our software is running properly, and that's awesome. But we also want to make sure that whenever we validate that our software is good to go, we want to pack it and send it to some place, right? So let me give you an example. Let's say you work at Facebook or Instagram, and you're working in a feature in your branch, and then eventually you merge that to the master branch. And then with continuous deployment, the idea is that the application, you did the development, the application is going to get tested, is being tested by yourself, and you're writing some unit tests locally, but then you're going to integrate those changes with your peers, and then finally, if it gets accepted, then you want to pack that application. So it's a web app, for instance. So Facebook, for instance, it's a web application. You want to pack that web application and push those to your web servers. So that way, whenever your user refreshes the page, they're going to see a live feed. They're going to see the latest version of your software. That's pretty much it. That's what CD is. It's an end-to-end process where I push code and that goes live. People can see it. That's production, right? In our case, we're developing a desktop application, and there's a bunch of companies that also distribute desktop applications. Let's think about one like Skype, for instance. And their CD process will be kind of similar to ours here. They need to validate, check that every single unit test is running properly, and then they will pack that application to an executable, and they will push that to some server, to some and it can be somewhere like on the web, can be their own servers, or maybe Amazon S3 or whatever service that stores data. And finally, they will make it available for their users. They're gonna generate a link and make that link available for their users. In our case here, we're gonna use GitHub itself to publish our software. So let me just minimize it here. So back to our example app repo. If we check GitHub, we're gonna see there's some options here. We have like the commits section, branch, and we also have a releases menu here. So a menu option. So if you click this here, that's a great place. That's exactly what we're gonna use in order to publish our releases. By now, since you guys already did the midterm, you already used this releases function. So it's nothing really new for most of you. But anyways, this is a place on GitHub where you can actually create a new release, and you can give it a name, a tag version, and finally you can just drag and drop some files here. And yeah, that's pretty awesome, right? So you could manually, let's say, we could generate our system, generate some jar files, drag and drop those here, and then click publish release, and then we have a release published, which means we're going to have a link to download our software. But we want to make this automatic. That's the entire reasoning behind continuous deployment, right? So we want to write a script that will not only test and validate our software, but it will create the release automatically for us. So that's pretty much what we're going to do right now. Okay, so let's get back to the presentation. And there are many types of continuous deployment processes. Maybe you're deploying a web application, and that will impact a bunch of web servers. Maybe you're deploying a mobile applications, and that means that your CD process will actually communicate with Google Play or the Apple Store. Or if you're doing continuous deployment for an IoT application, you may need to connect with your IoT devices remotely and push a firmware update or a patch to all of them. So those are all different. In our case here, we have a jar or an executable that we're going to push, and we're going to be pushing that to the GitHub releases page. So let's get into it. Okay, so first things first, let me go back to jobs here. The first thing we need to just look back is, let's open our editor. And right now, just a quick recap, we have our build Gradle file. I didn't change a thing on mine here. It's pretty much the same from the last video. We have plugins, repository, dependencies, test, and jar. That means that whenever I run Gradle test or Gradle jar, it will run the specific task associated to it, actually. And if I run Gradle build, it will run all of the tasks. And that's pretty much it. So for now, if we open our Circle CI file, the first version that we have, it was pretty much getting the code from GitHub, getting all the dependencies, so installing JUnit in every single dependency that we have. And finally, it was running Gradle tests, which means it was running this chunk of code here, and it was verifying that all the test cases were running properly. So yeah, so far that's what our file is doing, right? And this is pretty much the file that Circle CI gave us to us. So it basically gets some code out of GitHub, runs Gradle dependencies to install the dependencies that we listed on the Gradle file, and finally it runs Gradle tests, which runs all our tests, and it runs JUnit actually. So how can we change this file in order to do continuous deployment? Well, let's get into that, right? So first off, let me open here. I have a changed version here, an updated version. So the first thing that we need to change here is the Docker image. I'm not going to go much into Docker, but let's think about this for a second. Right now, Circle CI is provisioning a machine for us in order to run our software and validate our test cases and everything. And that's really nice. But how does it do that, right? It uses something called Docker, and Docker has this idea of images. And images, you can think about those as recipes with a bunch of specifications of what a machine needs in order to do a task. So right now, Circle CI provides has a bunch of images, and one of them is called Circle CI OpenJDK. So you can imagine that Circle CI OpenJDK is an image that has OpenJDK, and that's pretty much what it is. So Circle CI OpenJDK is a Docker image that has Linux installed and OpenJDK installed as well. But in our case right now, since we're going to do continuous deployment, we need a little bit more tooling in order to do that, because we need to communicate directly with the GitHub API and push something to the GitHub releases page. And this image here doesn't have the dependencies that we need in order to do that. So this image won't be sufficient for us in order to achieve our goal, right? So we're gonna. I actually wrote a custom image which has Gradle installed and Node, and we're gonna need Node to run the GitHub release part. Again, not gonna get too much into Docker. Just think about that as a recipe with all the dependencies that your machine needs in order to run the script, and the script is this chunk here. So for example, if I had a different image here, instead of an image with OpenJDK, I had something else, maybe whenever Circle CI tried to run those commands here, like checkout and Gradle dependencies and Gradle test, it would fail because Gradle would not be installed. So that's why your image is necessary. It has all the packages necessary in order to run the script over here, run the steps. So we're going to change ours. Right now you guys can use this. I'm going to leave a link in the description with this file here, this final version. But in a nutshell, we're going to be using this this image, and it contains Gradle and Node, and we need those for the CD part. An example of a Docker file, again, it's just interesting to know. Again, it's a recipe, so we can say here, oh, this is from Ubuntu, so we're gonna create an image from like the Ubuntu image, and then you can specify all the software that you need. So for example, oh, I need to install Gradle, so you can install Gradle here. I need to install Node, so you can install Node. Anyways, this is just more out of curiosity. If you guys are interested, check it out, the Docker page. They have like a nice explanation, and even like if you want to run your own projects, I would definitely suggest learning a little bit of Docker. It's a really useful tool. But anyways, that's the reason why we have this here, and that's the reason why we're changing this, because we need a little bit more packages and tooling installed. Okay, the second part is pretty much the same. Working directory is the same, environment, but the steps will change. So the steps are over here. The very first steps are the same, right? So the checkout step is basically cloning the repository to your machine. So it's basically downloading all the code to the Circle CI machine. Then we're going to keep the restore cache step. It's not going to change. Then we run Gradle dependencies. It's pretty much the same as here. This command will install all of the dependencies. In our case, it's just JUnit. We're going to keep save cache as well. And finally, we're going to run Gradle test. Same here. And Gradle test will let us know if the software is running properly or not, if the test cases are passing or not. In case a test case fails, this will fail, and the entire build process will fail, and it will go red. And that's pretty much it. And then the only change we're going to have here is we're going to add this last step. And that's where the magic happens. That's where we're going to push the jar file into the GitHub page. So let's see what's happening here. So we created a new step by calling run. We're naming this step build and publish release on GitHub. And this step is just a series of commands. Okay. So just to make this clear, this is a machine in the cloud. This machine is running Linux. That means that we can run, think about you're right in front of a terminal. That's pretty much the same thing here, but this terminal is in a machine. There's somewhere remotely. So right now we can run like just normal Linux commands. The first command I'm doing here is create a variable called now, and it holds the current date from the operating system. The second command here is basically creating a variable called zip file name. And yeah, that's pretty much how we're going to call our zip file, the one that we're going to push to GitHub. The file is going to be called example app, because that's the name of my repo, example app. So I'm just keeping the same name here. So we created a variable that holds example app. That's pretty much it. Then I create a tag variable, and that holds release, and it concatenates with the current date. That's it. So now is the current date. Zip file name is just the name of my app. You can put whatever name fits best for you. Like generally try to follow like your repo name. So if you call it, for example, project, I don't know, in the name of the class or whatever, then you can just copy that and use that, just so it's easy to read and easy to find out. And finally, tag is the variable that holds the release date. So it's going to be release concatenated with a date. Finally, we run Gradle jar, and just to remember, whenever we run Gradle jar, it's running this task here, the jar task, and this task will generate a jar out of our project. After that, we navigate to the folder with the jar. So we're navigating to build libs. Okay, so just for this, let me just run this here. So Gradle build, so it's, sorry, Gradle jar, so it's easier to explain. Okay. So Gradle jar will generate a build folder, and inside that build folder we have a libs folder that will contain our jar file. So let me just call ls. So here we go, we have a build folder, so cd build, and ls again, and then we have a libs folder, so cd libs, and ls again, and then we have the jar inside. That's pretty much it. So what we're doing here, again, this is a machine in the cloud, so we're running Gradle jar. So Gradle jar will generate a build folder, and then it will generate a libs folder inside of it, and we're just navigating inside that folder. So change directory to build libs. That's pretty much what we're doing. And then we call zip, and then we say zip file name, which is example app. And that's the name. So the zip file name is going to be the zip file name variable concatenated with .zip. An example app jar is the name of your jar file. So right now my jar file is called example app.jar, and your jar file should be probably called your app name.jar. So check it out. Run Gradle locally to validate which file name is being generated, because this guy needs to be replaced over here. And great, so this will generate a zip out of the jar file. That's awesome. And in case you have any external folders or anything else you want to include in the zip file, you can just add it here on the right side. So let's say I would have like a folder or something. I could add the folder here, or another file. You could, let's say another file.jar. You could add those here. So for instance, like some people, they separated their config app and their player app in two separate jars. Some people just wrote a single jar. So yeah, in case you have more than one file, just space it out and just type the name of the other file, and that's pretty much it. And the final command, the command that's going to do all the magic, is this guy here: GitHub release upload, and there's a bunch of stuff here. And so let's go through that. This is the most tricky part, I would say, because you may think like, okay, I'm pushing a zip file to GitHub, but how is it going to do that, right? So we're using a library called GitHub Release. It's a public library, and this guy has an upload function, but you need to pass some information to this function. The first one is a token. And yeah, you may think like, yeah, sure, you definitely need a token or some sort of password, right? Because we're going to reach out our GitHub page, and we're going to be pushing some files to it. So we want to make sure that whoever is doing that has authorization to do so. So that's where the GitHub token comes to play. In order to generate a token, I'm going to actually explain that right now. But before that, I'm going to just go through this entire string. So we're going to need a token. Then we need an owner. So, okay, besides the token, I need to know who owns the Git repository. Then we need to provide the repository name, because we're pushing something to a repository, right? Finally, we need to specify a tag, a name, and a message. Okay, so let's do this. So the first thing we need to do and to provide is a token. So let's get a token, right? So GitHub token. Right now, you may have noticed that some variables we declared locally. So zip file, tag, now, all those variables, we can just declare those locally. They're not sensitive information, right? This is just the name of my application, the current time, and that's pretty much it. That's not sensitive. But a GitHub token, that's definitely sensitive information. We don't want to put this in the file. This file will be available for anybody to access, right? So the GitHub token is a variable that needs to be somewhere else. And actually Circle CI handles this really well. It has this idea of environment variables. So think about this as variables that you can store inside Circle CI itself. So that way you don't need to put inside this file, because this file is public. So let's do that right now. So we're gonna open my repo. We're gonna open Circle CI. So to navigate to the configurations, click on your project here, and then you can either click here on this cog or click over here on project settings. Finally, navigate to environment variables. And actually, I already established those. I'm gonna remove those for now. Okay, remove, and remove. And let's add those from ground zero. So here we go. So the first variable that we need, first variable that we need is GitHub token. So let's copy this here, and let's add variable GitHub token. And we need to generate this token. How do we generate a token? It's actually quite simple. Open your GitHub page. You're gonna click on your profile. You're gonna go to settings. Then you're gonna go to developer settings, personal access token, generate new token. Yeah, just type your password. and you give it a token description. So we're going to call it Circle CI, and you specify the scope of access of this token. In our case, we want the token to have repo access and also admin repo access, so it can write stuff to the repository. In this case, we're writing a new release. So yeah, that's pretty much what you need: repo and admin repo hook. Then click generate token, and great, it gives you a token. Let's just copy here, go back to environment variables, right click, paste the value, and add the variable. We're gonna add more variables actually right now. Let's go back. We have a second variable called project username, so we're gonna copy this and go back. Project username, it's pretty much your GitHub username. So let me go back here. So if you created this GitHub account, if you created this repository, you have access to it, right? So we pretty much need to give our username to the library in order for it to work. So my username is Daniel Mapar, so I'm gonna just type that out. Okay, so this is my username, this is the token associated to my username, and we have one more variable that we need to add, and that's the project repo name. So we're gonna copy this, go back here, paste, and the repo name, it's just this guy here, example app. So yeah, so it's generally the repo name is your username dash the repo name. So this is the name we're going to use right now. Let's paste it over here and add variable. So that's pretty much it. So that's really cool, right? So Circle CI stores that information to us, and as soon as it generates it, you're going to notice that it's censoring part of the data. So even if somebody tries to look at afterwards, like the token value or something, they won't be able to. That's encrypted and that's stored inside Circle CI itself. And that's also nice because now our file doesn't contain any sensitive data. So if somebody has access to our code, they don't have access to our tokens. Okay, so we gave everything. So we have the GitHub token that's going to be provided by Circle CI. Project username is also coming as an environment variable. Project repo name as well. Tag is pretty much this variable here where we made tag to be release concatenated with the date. Then we have name is the tag as well, and body is going to be release date and now. So you guys are going to see that. Also, you're open to change this. You can definitely change the body message to something else if you want, and the name you can also change it to something else. I'm just using the tag because that's enough. And here we're going to specify our file. So zip file name, which is the variable that we established here, .zip. So this is the file we're trying to upload, right? And this is the file that we just generated here. So zip file name .zip. It's exactly the file we're trying to upload. So that's it. So again, walking through this code, we created a variable called now. We created a local variable called zip file name, which is the name of our application. We created a local variable called tag, which concatenates release with the date. It's just a string. Then we run Gradle jar. This generates our jar file. This jar file will be located inside the build libs folder. After we navigate inside this folder, we can zip and create a zip with all the jar files we have, or everything that was generated from the build. And finally, we can just call GitHub upload, and that upload will push the file to GitHub for us. That's simple. That's pretty much it. There's also this final part here, and I think that's important because I didn't add this in the last video, but it's quite relevant. So one thing that you may have noticed is that with this setup here, what's going to happen if you just keep the Circle CI file is that whenever you push to whatever branch, so let's say you have the master branch, but then you have a feature branch, and your teammates have their own branches. Whenever anybody pushes, Circle CI will run the build process, which is fine. But for now, especially now that we're doing deployments, we don't want that, right? We only want deployments and releases to be pushed to GitHub whenever the master branch gets some new code. So so we need to write we actually need to write some specification in order to do that. So in order to do that, we're going to write workflows version 2, build, jobs, and then build again. So jobs right now, it's basically pointing to this guy here. And right now we only have one job that is called build. So we're basically telling Circle CI that, hey, whenever you build the build job, you're going to filter that, and you're only going to do this for the master branch. So only when we have new stuff inside master, you're going to run this entire process. And again, the way we have established from the last video, no matter what branch you push, it's going to run Circle CI, which is totally fine. But now that we have deployment, we want to make sure that only whenever master gets new code, we're going to push a release to the GitHub page, to the releases GitHub page. So we need to add we need to add this little chunk of information here in order for Circle CI to be aware that it should only take into account master changes, master branch changes. Anyway, so let's see if this works, right? So we can save this file, and sorry. Here we go, save it. And let me just come back here to the console. I'm going to just call git add all, git command, create release. Okay. And we're going to do git push origin master. Okay, perfect. So let's just give it one more check inside the releases area. I have nothing here yet. Let's open workflows. I don't have anything yet here. So let's run this right now. Okay, so the code got pushed. Let's refresh. And we have a new task running. We can click it over here. So it's spinning the environment and everything. It should take a while. Starting the container. It's basically provisioning. Again, it's running all that code to get all the libraries that we need in order to run our script. Yeah, and okay. And as you guys can see here, the environment variables that we set up inside Circle CI, those get injected inside the machine. So Circle CI project repo name, username, and everything else, it is injected. So the GitHub token is probably here as well. But anyways, all those variables got injected. Right now it's running Gradle dependencies. Saving the cache. It's running Gradle tests. It's checking to see if all the tests. So that's the fun part. If Gradle test fails, we're not going to push a new release, right? Because it's going to fail the entire build process. So it's running the test right now. And that's a really cool thing. So if the dependencies failed, for example, it would fail the build process. If the test failed, it will happen the same thing. It will fail and it would not deploy. But in case both dependencies get installed and the test passes, that means that it's all good to go, and then it's going to build and publish the release on GitHub. Okay, and it was successful. So as you can see, it ran our command, it created the local variables, it ran Gradle jar, it did the zip process, and then finally it uploaded it. So yeah, so it compiled the jar here, build successful. Finally, it generated the zip, and it created our release. That means that, okay, great. So if we refresh the page right now, we should see something. Yep, there it is. So we have a release here. If I click example.zip, it downloads it to me. I can open it, and there's my jar file. I can double click it. Right now it's just a console application, so I would actually need to drag and drop it to the console. Or maybe I can do that. Let me see if I can navigate it. Oh, okay. It's inside the zip file. Anyways, you should be able to just double click your jar file, and you guys have an interface, so the interface will boot and everything. And that's pretty much it. Now you have a continuous deployment pipeline connected to your project. Not only we're downloading dependencies and testing everything, but we are also building and pushing those releases to somewhere else. In our case here, the GitHub releases page. And it's super cool because now that you have releases, you can have a release history. That means that, okay, let's say I come here in the code. Let me just jump over here really fast. Source main main.java, and then I change this to new, task new. And if I come back here and I add all, commit, then added new code. And if I do git push origin master, that will push, that will trigger the process all over again. So inside jobs, we're gonna have a new process kicked in here for us. And again, it's gonna spin up the environment, it's gonna do all that stuff again. And by the end of this process, we're gonna have another release here. And that's why I ended up like using the timestamp, which is the current date, so year, month, and day, with the hour as well, because that makes more sense. So then we can, for example, release date, it was Monday, February, so I know this is when this release was made, but you can put whatever message you want. Just remember to go inside the script, to your Circle CI YAML file, and you can change that over here on the body side. So this body here is pretty much the message that is showing it over here. So feel free to play with that as well. It's not mandatory to use the timestamp, because you will also get the timestamp from GitHub itself over here. But I ended up like using it just for simplicity. Anyways, we have the process running all over again here, Gradle dependencies, and yada yada yada. And right after that, we should see 2 entries here. And the thing is, whenever we push something new, the latest will get updated to the release that is going to be generated by this guy here. And that's super cool. So let's just wait a bit. This process takes a little bit of time, but it's free, so can't complain. Okay, saving the cache again. And those machines are really useful. So you can think about like CI, it works for code, but you could have like versionings of documents as well. So right now, if you have your documents, your test document and your user guide, those will have versions as well. You can put those in your GitHub repository, and if you whenever you pack your jar file, you can pack your jar file together with those files. So the zip will contain everything. Great, so it finished the build process here. Let's refresh. And now we have 2 entries here. This is the latest, obviously 10 seconds ago, and 5 minutes ago it's over here. And there was 1 commit difference between the two of those guys. So if you click the commit, you're gonna see that I changed test to test new. And that's pretty much it. That's pretty much everything you need to know for continuous deployment for this class. Yeah, if you have any questions, leave that in the forum. I'll be more than happy to answer. And that's pretty much the process. Thanks for watching.